Hello and welcome to another nostalgic rumble. Today we are looking at an equation. Sorry, thank you. Um, that was not directed at you. Question. No offense at all. Um, right. 3 to the y plus 1 divided by 32 is equal to the square root of 96 to the x. So determine the values of x and y. Interesting. So my instinct here is to just rewrite everything being the numbers, in terms of their primes. And the reason why I instinctively want to do that is because I just realized that 96 is the same as 32 times 3. So we might not even actually need to go all the way down to prime factors, but yeah, we could just use 32 and 3 and see how far that gets us. So 3 to the y plus 1 divided by 32, and the 96 we can rewrite as 3 times 32 to the x, which is the same as square root of 3 to the x times 32 to the x, which we can rewrite as 3 to the x, well, the square root of that, times the square root of that, right? Because you know that square root of a times b is the same as square root, right? This is actually just an extension of, you could rewrite it as, all right, and we know that if we have a times b to the power of n, you can just do that, right? So this would just be the same as a to the half times b to the half, which is the same as square root of a times square root of b, right? So that's what's going on there, right? So this is then the same as 3 to the, yay, so there's a little invisible 2 over here. So this is the same as 3 to the x over 2 times 32 to the x over 2, right? And again, this is using the idea that a to the m over n is the same as the nth root of a to the m. So in this case, our n is 2 and our m is x. Okay, righty dudes. So that's for this part. Okay, so that's what's happening on the right hand side. Let's see what's happening on the left. So on the left we have 3 to the y plus 1 times 32 to the minus 1. Okay, and so what this suggests to us is, therefore, y plus 1 should be equal to x over 2, and minus 1 should be equal to x over 2 as well. Alright, so y plus 1 is equal to that guy, and minus 1 is equal to that guy. Right, so this one is same one variable, so let's lead with that. So that's going to be times by 2 on both sides, so minus 2 is equal to x, or what divided by 2 gives me minus 1, or minus 2 divided by 2 gives me minus 2 divided by 2 gives me minus 1. So that's our first solution. So this is equation 1, and that one was equation 2. So now we can sub that into the first equation. So then we have y plus 1 is equal to minus 2 over 2, which is the same as minus 1. And then that means y must be equal to negative 2 as well. Interesting. Alright, so that is the solution. So x is equal to minus 2 and y is equal to minus 2. Right, and just to show that, you know, if you hadn't happened to know that 32 is a factor of 96, 3 is a factor of 96, let's do this question again just using prime factors. So that's always a useful thing when you're dealing with equations involving unknowns in the exponent, it's useful to try and just get as many common bases as possible. And common bases often just means get things into their prime factors. So 3 is a prime number, so that's done. 32, and this is something you can do on your calculator. I just need to remember how you do it. I think you say 32 and then you say shift. Yeah, okay. So then it gives you, so we know that 32 is equal to 2 to the 5. And then the other number we're concerned with is 96. So I'll enter it into the calculator and then shift fact. And that gives me 2 to the 5 times 3. So then I can rewrite the equations. So the top will remain 3 to the y plus 1. The bottom will become 2 to the 5. And then over here we have 2 to the 5 times 3 raised to the power of x. So this would still be 3 to the y plus 1 times 2 to the 5. And over here we would have 2 to the 5x times 3 to the x. And then I would rewrite this as a product of squares, square roots. And then again, use that law that we used previously to rewrite this as 2 to the power of something times 3 to the power of something, so that it looks like this side, right? So now we know that this is 2 to the 5 times 3 to the y plus 1. And so, that means that these two should be equal. So 5 is equal to 5x over 2, and these two should be equal. So y plus 1 is equal to x over 2. So times by 2 on both sides, and we have 10 is equal to 5x, and so therefore x is equal to 10 over 5, which is 2. And then on this side we'll say, well, y plus 1 is equal to 2 over 2, which is equal to 1, minus 1 on both sides, and we have y is equal to 0. Oh my gosh. Oh, oops. Okay, mistakes were made. This is why we're ending up with different answers. Spot the mistake. Ugh, carelessness, that's the mistake. This is 2 to the negative 5, right? And so, let us clean up. Wow. Okay, you get the point. Okay, no, my soul will not rest. Oops. Okay, so that is minus 10, and this would then become minus 2. And then over here we'll have minus 2 for our x, and so that becomes minus 1. And if we then minus 1 on both sides, we don't end up with 0, we end up with minus 2, which is pretty much what we got before. So yeah, when working with exponential equations, often a good idea to get your bases into their prime factors and then take it from there. Let's see if the memo agrees. Yep, x is minus 2, y is minus 2. So they even, just from the jump, they start out by writing this as, they start out by writing this as 96 to the power of x over 2. And then, you know, whether you go with the prime factors or whatever, you can just take it from there, instead of going through my whole spiel of splitting up the square roots and all of that. So that's definitely another approach you could take, but all roads are leading to Rome. Cool. That's that on that.